Okay, so for question number 1, okay, we've got beryllium sulfide, which is an ionic compound reacting with bromine, which is an element, happens to be a non-metal. So this is going to be what kind of a reaction? Single replacement. Who's bromine going to replace? Sulfur. Okay, so we are going to have beryllium end up with bromine, and we are going to have sulfur end up by itself. Okay, now we've got to have these things correct in terms of their drop and swap, or if they're special. So we know sulfur is special. It's an 8, and this has to be dropped and swapped. This is a +2, and this is a -1. So we got Be, Br2. So give them 1 mark if they have Be, Br2, and 1 mark if they have S8. Okay, they predicted the products correctly. Now their last mark will be for balancing. All right, start with sulfur, go back over here and make 8 sulfurs. That gives me 8 berylliums, so I have to go back over here and make sure I have 8 berylliums, which gives me 16 bromines. So I need 8 times 2 is 16 bromines there. All right, so that should be their balancing. That's 3 marks. Questions on number 1? All right, on number 2, I have nitrogen gas reacting with potassium. What kind of a reaction is this? Synthesis. What kind of compound is going to form here? What do I list first in an ionic compound? Right, see, it was C. It's like what is that called in English? Foreshadowing. Okay. I told you I was going to do that at some point. Okay, so I got K with N, and we have to have this dropped and swapped correctly. So first off, they can have a mark if they wrote it in the right order before I even drop and swap it. 1 mark for writing in the right order. Okay. Then we got to drop and swap it correctly. It'll be K3N. They can have a 2nd mark for having it dropped and swapped correctly. Such a generous guy. Okay. And now we got to balance. So if I put a 3 here, I'm just going to be starting over again because it won't affect my nitrogens over here. So I'm going to balance the nitrogens first. Okay. Now it works, and I'm going to need a 6 here to make the potassiums work. 1 mark for the balancing. Questions on number 2? Okay, with number 3 here, I've got copper 2 sulfate reacting with sodium hydroxide. They're both ionic compounds, so this is a double replacement reaction. So what do we do in a double replacement reaction? Swap the metals. All right, so Na is going to end up with sulfates, and copper is going, well, I better leave enough room for the balancing numbers here. Okay, copper is going to end up with hydroxide. Okay. So now I've got to drop and swap my compounds and make sure that they're okay. Sulfate's a -2, and sodium is a +1. So we got Na2SO4, 1 mark for that compound being correct. And this is copper 2. How do I know that? Because there was 2 on the other side, right? I figured it out over here. Sulfate was -2, so copper had to be +2. All right, so copper's a +2 here. Hydroxide's a -1, so I'm going to need brackets around the hydroxide with a 2 outside of them. 1 mark for that. No, they have to have the brackets. If they don't, then it doesn't say the same thing. Yeah. It would say there's 2 hydrogens and 1 oxygen. It's not the same. Yeah. Okay, now we've got a balance. So 1 mark for each of the compounds there. Now we're going to balance this thing. Okay, I'm going to start with the sodiums. Putting a 2 there gives me 2 sodiums. It also gives me 2 hydroxides, and there's 2 over here. Everything else is a 1, so we're balanced. Question? I'll let them have it, but in the future, they shouldn't. Okay. You don't put brackets unless they need a number outside. No, he didn't get the balancing right. If he doesn't have if they don't have brackets here, guys, they don't have the balancing right for this reason. Okay? If I don't have brackets here, I only have 1 oxygen on this side. And going back over here, that I can't make that work, right? So I have to have brackets. Otherwise, I may have the same numbers, but I'm not balanced. Okay. All right. So we now have the next one here. So 3 marks for that one. Okay. Number 4, I've got a hydrocarbon. Okay, reacting with oxygen. So this is a combustion reaction. What are always the products? CO2 and water. Okay. Special balancing rules. Do I need them both? Yes. All right, so we start out with the rule of 2. Okay, 2 times 4 is 8, so I go back over here and make sure I have 8 carbons. 2 times 10 hydrogens is 20. 10 times 2 hydrogens is 20. And now we look at the oxygens. So in the carbon dioxide, I have 16, and I have 10 more here for a total of 26. 13 times 2 is 26. No, you're going to get 1 mark for the balancing, 1 mark for carbon dioxide, 1 mark for water. No, if it's even. I don't use it if it's odd. No, it's odd number of oxygens, right? If I don't put a 2 here, I'll have an odd number of oxygens on that side, and I won't be able to multiply a whole number by 2 here. I'll get a decimal, and I can't have that. If I have an odd number of carbons, it works just fine. Okay, that odd even thing has to do with other reaction types. Okay, don't apply any other balancing rules to combustion reactions. It has its own 2 rules, and those are the only 2 rules that apply. All right, for number 5, I've got 1 compound here. It's manganese 4 chloride. Okay, what kind of reaction is this? It's a decomposition reaction. Okay, so it's going to break down into manganese and chlorine. 1 mark each for those products. They must have it written as Cl2 because chlorine is one of our molecular elements. Okay, then we need to balance. There's 2 chlorines on that side. There's 4 over here. Now there's 4 over there. Okay, so 1 mark for that. Each one is out of 3. Give them a mark out of 15. Put it at the top where I can see it. Give it back to them, and then I want to pass to the front of the row so I can collect them.